My name is Jim Josephs. I work with a company called Expeto Wireless. I am a solution architect. I've been working with the company for about 5 years. So, Expeto, you probably may not have heard of us. If you're an auto OEM, we're hoping you'll hear from us for sure. We are specialties in connectivity in the mobility space. And to be clear here, it's mobility as in cellular mobility networks, not mobile networks or mobile vehicles, because mobility is a very overused term here, of course, in this hall, but this is about cellular networks. We're a startup company going into our scale-up mode. We're introduced and working with Amazon Partner Network, and through them we got introduced to some automotive industry expertise here, and we're finding out there's some pretty big challenges in the connectivity space for auto OEMs, and we believe we have an awesome solution working with Amazon to help you solve that problem. We're currently working with a large German auto manufacturer, and we have a test fleet of cars roaming around the US right now on that, and hoping to scale that up with that company and many others. So what's the problem that we're trying to solve here? People have been looking at connecting things a lot of times to the cellular networks. We have, we have a third generation. First generation is that you had a SIM-enabled car, and that connectivity basically allowed the car to connect to the internet. But internet has a lot of problems on the public internet. Second generation may have been some companies that were like global IoT aggregators or IoT SIM manufacturers or what they call MVNOs, mobile virtual operators. But that is a second generation, but it still puts a lot of the control in the hands of the carrier. So auto OEMs have to deal with multiple carriers around the world, around multiple jurisdictions. And each one of these carriers have different APIs and different interfaces and different control planes and different data planes. And really what auto manufacturers want is they want a network just like they have all their other networks. They want to have a TCP/IP network that connects the car to the cloud. Another problem with working with some of the carriers is that there's a long cycle time. When something goes wrong, if it's all working, it works fine. But when something goes wrong, there's long cycle times to get things resolved. You create a service ticket, it might have to get triage, a week later it might get to a group. And a lot of times the auto manufacturers, it's a simple TCP/IP or a networking problem, right? It could be something as simple as a DNS or a whitelist that if it was in the control of the OEM, they could just fix it like they do all their other problems. But with a carrier, some of those simple problems take weeks to get fixed or weeks to even just diagnose. So we help shorten that cycle time. So what we provide is we're a software company, first of all. So we don't provide radios, we don't stand up radio networks, but we're the software core to 4G, 5G networks. So we are an extension to the carrier's network. The fundamental thing is that we are not a rip and replace. We are actually sitting alongside carrier networks, and we have taken the monolithic large appliance network cores of like the Ericsson and the Nokias and the Huaweis, and we broke them up, modernized them, and distributed them. So certain elements reside with the carrier, certain elements reside with the OEM. But we create a control plane and basically tether that TCU in the car, the telematics control unit, from the car all the way to the cloud. So now the OEM can treat that remote vehicle car just as if it was sitting in their data center and control many aspects of it. I'm talking about connectivity over public carrier networks, like a mobile network, like AT&T and Verizon or Vodafone or whatever around the world. But also, because we are a network core software provider as well, we provide a full platform for network management, SIM and subscriber management. But because of that, we can also now work with an OEM and follow the life cycle of the car. So now we can drop a private 5G network in a factory. And on that network, they can use it to enable any type of wireless connectivity. It could be robots, it could be security cameras, it could be autonomous part tray robots, it can be connected workers. And of course, even in the car itself, it will have that TCU and be connected in the car. After it leaves the factory, now this is a challenge right now, is that they have wireless networks in the factory, but they don't bridge and roam over to the public networks. Ours actually can seamlessly migrate from a private 5G network onto a public network. And it really allows the car to be in the same connectivity and security profile from the factory to the dealership to the customer, and provides a complete end-to-end platform that way. So it's the connected car platform that goes from public to private And when that customer's car maybe goes into a private zone at a dealership or an EV charging lounge, you can bounce back onto a private network and now take advantage of higher speeds for OTA updates or larger OTA updates or larger diagnostic uploads, because now these cars are software defined and censored so much that they have so much data to deliver that the actual plumbing can't handle it all. So when it's at a certain zone, it can now start uploading this data. So at a 50,000 foot level, this diagram tries to explain it, and there's a whole lot of 3GPP protocol type stuff behind it all, because that's one nice thing about our software platform. It's not a new wireless technology or a proprietary wireless technology. Cellular networks have been evolving for 30 some odd years now, 2G, 3G, 4G, and 5G. So what this diagram is showing you is that the Expeto gateway aspects live inside the carrier networks beside their MNO core, the mobile network operator core. We have some patented technology that allows us to then pull that data off that network to the Expeto Edge. And the Expeto Edge is actually the network element in a 4G and 5G network where it unpacks it out of the radio network or the control plane. One big aspect of it, though, is with the AWS partnership, is that you get to use cloud-native tools, your AWS tools that you're already used to using, the AWS tools, or any other third-party network-type monitoring tools that run on top of your cloud, right? So AWS provides a wide range of tools to watch your infrastructure, your network. They've got CloudWatch. They've got a whole bunch of stuff, and then you can scale up and scale down with their Kubernetes clusters. Now you can have dynamic nature of being proactive instead of reactive of your network. So if you do have a large OTA update, you can on certain regions, you can scale that up. And going back to that previous diagram, you can segregate and now try to automate some of your OTA updates. So maybe you need updates on the East Coast to start on a Monday and on the West Coast to start on a Wednesday. But now you can actually have segments of data traffic going that way. And as cars become more software defined, you also have the ability to now segregate where the traffic is going, right almost down to the same level as a source code tree or the certain stream or fleet or model. So if it ain't broken, don't fix it. Because a lot of times in software development, you'll do a software fix and you'll roll out that patch. And because of the large nature of the millions of lines of code, it's hard to regression test for every case. But now you can actually separate it. So maybe only the 2024 certain fleet or model of a vehicle gets a certain chunk of code, and all the previous ones, you can program them based on what's called IMSI steering or the SIM card. You can actually tell it where to go. So now you can align the car and tie it back to a source code tree and create stable code and allow more mobile updates to happen in a more controlled fashion. So kind of wrapping it up, so one of the big values we provide is we abstract the complexity of the telco networks away from the OEM, right? Because they're very complex, there's many of them. You can have one standard worldwide architecture. So it doesn't matter if you're a manufacturer in Asia, North America, or Europe, you have one platform. And it's similar to all your other types of things you're standardizing on. You standardize on your batteries, you standardize on your TCUs, you standardize on your sensor technology. And why does connectivity on your mobile networks have to be so segregated and legacy decades old technology? So we leapfrog decades of older architecture and legacy technologies that the carriers are offering and allow an OEM to have the network the way they want to consume it. It's virtualized, of course. It's all modernized. So now you can virtualize in the cloud. You can virtualize at a factory. You can distribute elements around it and have it running in factories, EV charging stations, dealerships, or in the cloud roaming on public networks. And when that vehicle does even cross jurisdictional boundaries between, say, Canada and USA, you can have these networks actually become seamless. And the carrier now can actually work on a situation where they may not have to have multiple carrier and roaming agreements all around the world. Control and visibility is a huge thing for the OEMs because now they can actually look at that data packet as it left the car. So when that packet leaves the TCU, it doesn't have to traverse through a carrier network and to the intranet and then finally land on the OEM cloud network. and with one of our manufacturers that we're working with right now, they're seeing like great improvements in latency and performance, like going from 150 milliseconds down to 50 milliseconds, because basically when the packet egresses off the mobile network via our Expeto Edge technology, it's already in the cloud. It's already in your AWS cloud. So it doesn't actually have to bounce around and go through carriers, firewalls, and whitelist and security systems. It actually is going through your own OEM systems. Integration with IT systems is big too. As I mentioned earlier, currently a lot of OEMs are dealing in obviously many countries, many carriers, and each have their own separate type of interfacing. Some have APIs, some don't have APIs, and you have to build multiple APIs. But now you can build one common API into one platform, and it'll operate anywhere around the world.